Domain-driven design. Let's talk about one way to design software that I think works really well and is a very good way of doing it. Started with a book. This book, the Blue Book, they call it in the industry. Domain-driven design by Eric Evans. It came out in mid-2003, which is 21 years ago now. It's a tech book that is still relevant in 2024. There are not many tech books that have been written that are still relevant 20-odd years later. And I include the books I wrote after this book was written, which you should never, ever read. Okay, the reason this book is still relevant is in the subhead, Tackling Complexity in the Heart of Software. Because software and writing software is complex, it's a complicated problem. And we've been trying to get better at it for the entire history of making software, and we're still not very good at it. So what I want to talk about today is some approaches to try to make understanding and designing a piece of software that is non-trivial, doable and maintainable. This comes about because we need to understand something called the domain. So domain-driven design, the domain is the key part of this. What we're talking about is understanding the problem from our business's point of view. And now I've introduced yet another term, and you will discover very, very quickly that there is an awful lot of jargon. So when I say the business, what do I mean by the business? I mean the people who actually need the software, the people you are writing this piece of software for, this application for. I do a lot of work in the insurance industry, so from my point of view, the business are the underwriters, the claims agents, the people who run insurance companies. They are the business. They are the people who understand the problem that I'm writing software for. Domain-driven design is a large topic. That Blue Book is 400 odd pages long, I think. It's not a small book, and it's quite small text as well. There's a lot of copy in there. And it can be divided into two halves. We have the strategical side, which is big picture. So the strategy behind the way we're going to design our software, the direction of the business, the big picture stuff. And then we have the tactical design. And this is the nitty-gritty, the details of how we use our design and put it into software itself, write the code itself. I'm going to start with the strategic. Domains and models. We solve complex problems by creating models of them, which again, yet another piece of jargon. By model, I mean we create a representation of the real world that meets our needs, our understanding, a way to take a really complicated thing and make it small enough that our little brain can understand it. That's essentially what I mean by a model. A domain is the problem we are trying to solve, or the problem space we are trying to solve, or write our software for. So going back to my insurance world, purchasing software, that is the domain problem. Another example is a map. This is a domain model. This is a very famous domain model. You've all recognised that, even though it's an absolutely terrible picture from way back in the days before colour photography had existed. The London Underground map is a really, really good example of taking a complex domain and creating a great model to help people. So what's the domain? The domain is the London Underground Railway network. What's the problem space? People need to find their way from one station to another station. They need to get from Harrow to Barking, or from Paddington to Liverpool Street. How do they do that? That is the problem space. Henry Beck, in 1931, came up with the tube map, which solves that problem really, really well. But is absolutely rubbish as a model for the engineers trying to maintain the track. Because that problem space for the engineers is a completely different problem for the people who need to get from one station to another station. So we need a different model for that. So the tube map, fantastic for the problem of planning your journey. Civil engineering drawings, far better for actually maintaining the railway. Different models for different problem spaces. This is all what a domain model is. So the domain is something in the real world. It's normally a set of processes that involve people. Normally, we are talking about achieving a goal. So we have a problem, we have people, we have a process, we get a solution. That's what we're writing our software for, normally because there is a real-world thing that needs to be done. The domain is therefore the subject of our software project. So the problem space. It is understood by experts in this space, not by the developers. As a general rule, my knowledge of insurance is nowhere near as good as the people who are actually insurers. Funny enough, their knowledge of building software is not as good as mine, no matter how much they think it's just a little problem. Another thing about experts, and you will have already seen this amongst your own teams, is that if you ask two experts to explain the problem to you, you will get two different answers, if you're lucky, and possibly three or four. Very, very rare to get pure consistency when you're trying to understand your domain. So our domain model is a representation of that domain. It communicates the problem space between our domain experts, the people who know the problem, the people who are writing our software for, and us, the developers, who need to write the software in the first place. We need a way to talk together. We create a domain model for this. Hence, it is an abstraction of reality, which is why the tube map is such a good example. It's very essential. It is not the full picture. It is just enough information for us to write the software we need to write in the context that our customer needs it. And it's a concept. It's not a particular diagram. It's not a particular document, a specification. It's not the actual tube map. It's not the code base. It's all of those. They're all expressions of your domain model. I got way too much text with that. It's all very boring. So I'll skip it. Saying that out loud so that catches it, so I can fix it for the actual talk. So, how we have build domain knowledge? I'm the developer. I'm building this insurance website. The insurers know what they want to get solved. Somehow we need to get that knowledge over to me so I can build the software in my team. Comes down to language. It comes down to talking to people. We have everything in common with America nowadays, except, of course, language. Oscar Wilde. Pretty sure he said that. That's who everyone attributes it to. He almost certainly cribbed it off someone. But the point is that we don't talk the same language. We use different terminology to mean different. So we use the same terminology to mean different things, different contexts, based on our own experiences. In the insurance world, I might use the word policy for an insurance policy. My insurer will never ever use the word policy for what I mean a policy to be. They will use the word risk. Policy is something slightly different. That's a sales thing, not an actual thing that an underwriter deals with. Claims, MTAs, all the other jargon, all the other stuff that is in that world, I need to understand. I will also link developer terms to my insurance colleagues. I will start talking about message queues. I'll start talking about databases. I will use words like objects and things like that. So we need to make sure that we're all on the same page. And we do that through something called ubiquitous language, which is possibly the most important thing about domain-driven design. You could forget the rest of this talk if you just pay attention to this bit, because this is the bit that really, really makes a difference to the average software. The thing about ubiquitous language is that we are trying to avoid talking at cross purposes. Talking at cross purposes is the most expensive mistake you can make in software development. When your customer asks you for something, you think you've understood what they've said, and you go and build it, and then they say, "That's not what I meant." You have failed at communication. You have not shared the same language when you were talking. Now imagine a really big project and not just a little feature. All over the place we can go wrong. So we want to have an agreed set of concepts, agreed set of meetings, terms that we're going to use for our project. And with this we can build our domain model that everyone agrees represents the problem that the software is going to solve. So ubiquitous language is a common language or vocabulary between developers and our domain experts. It's limited to the domain problem. We don't try and solve and define every term that your customer has ever thought of in their business. There's an awful lot of them and nobody cares. Only the bits that are related to our project are the ones we care about. You have to talk. This is how we create our ubiquitous language. We get in a room and we talk about the problem. We explore how the business operates. So, well, how does this work? How does that work? How does the other work? And we communicate. Well, in software, we can represent with a database table. It's a bit like an Excel spreadsheet, but better. Words like that. It's foundational. I've said this before. It's really, really key to getting a good outcome for your software project. If we get the language correct, then our business people can explain the problem to us, and we can develop a solution that actually solves their need. And when we do that, they make more money. And when they make more money, they pay us more money to build more software. It's a lovely circle that works really, really well. If it doesn't work well, then they hate software and they go and get another supplier and we lose our jobs. Not so keen on that bit. Everything revolves around this. We are going to keep this updated. So throughout the project's life, from our initial design all the way through build, through Q&A, into maintenance, we are going to learn more and more about our problem space. We are going to get better at understanding the words of our business. We are going to come across better terms to represent the things that we thought we understood. When we do that, we will update all our knowledge about it. We will refactor our code base to use the new words. Talk about London Underground. We might have called them customers. Nowadays we call them, we might have called them passengers. Now we call them customers. So we would update our code base to start using the word customer, not passenger, because that's the terminology of the business. This is ubiquitous language. So now we can talk to our domain people and they can tell us the problem they want solved that we're going to write the software for. How do we go about creating the domain model? I have some thoughts. Firstly, unless you are a genius, and I don't discount the fact that there might possibly be one in this room. Sorry, but it's unlikely, but it's possible. Yeah, not you, Dave. Your first idea to represent the problem space simplified as a model is going to be maybe not the perfect solution. Domain models are refined and iterated on. They require multiple go-rounds as you understand more, as your business people understand how to talk the right words so that you understand what they're trying to tell you. Don't model what doesn't matter. Only model what is needed for this business use case. Experts love to talk. You'll notice this. Get me with a pint in the pub and I'll talk for hours about something. Loads and loads of detail. And my insurance company colleagues will do the same. If you go and talk to anyone about what they do, they will tell you reams of information if you're prepared to listen. Most of it is not needed for the problem you're trying to solve and is not needed in your model. We need to constrain it to our problem space. Focus our effort where it matters. And where it matters is what we call the core domain. The bit of the project which is the reason we are writing it. Not every piece of the software that you're writing is absolutely important or key. User login systems. There's a classic example. You probably don't need to spend too much time thinking about the user login system. That's been done before. Just use the one that's built into Laravel if you're using Laravel. But just use a standard system. You write in an API, just use OAuth 2. Don't spend time on that. It's unimportant. It's not the reason people are buying this software. People are buying this software for the key domain, the core domain. That's the bit we care about. That's the bit we want to model. We do it through something called knowledge crunching, which is possibly the worst phrase I've ever heard. Oh, no, it's maybe not. So it is absolutely the worst one in the DDE book. I don't like this phrase at all. The concept of knowledge crunching is probably an American concept, but we're going to distill the relevant information from our problem domain into our model. We're going to collaborate with people to do this, and we've got to do it in a way that they are prepared to give us that information. Nowadays, the most common way we do that is something called event storming, or at least this is the most famous way, I suppose might be a better way of phrasing it. It's the one with the most buzz nowadays. This was invented by someone called Alberto Brandolini in 2012. So it's been around a while. So this technology, these ideas have been around for a while, so they are battle tested in a lot of ways. And it's all about the big picture. And I'm going to use the word fun, but yeah, it's still work, isn't it? It uses post-it notes, it uses a whiteboard, it uses a workshop-style feel. So it's slightly more interesting than having a Zoom conversation. You can event storm over Zoom if you have to. And the basic idea is, we have a problem to solve. Our domain experts know what the problem is and know how to solve it, or at least know the processes they currently do manually to solve it. And we're going to learn software, so we need to write it down in a fairly good way. First of all, we find what we call the events, the domain events. These are the things that happen that cause processes to occur. A user purchases insurance. A user tries to edit insurance. A passenger tries to work out where their destination is on the map. Those are all events. For each one, we work out the command, what we're going to do as a result of that event happening. We also work out who is involved with that particular piece of process. The customer's involved, this back-end office person is involved, the underwriter is involved, whoever it might be. We are writing down, as a set of post-it notes, the problems and processes that are required. And it's quite informal. This is why it works so well. Anyone in the room can pick up all the post-it notes, put it somewhere else where it fits better. Anyone can write down a new post-it note and stick it on the board. We forgot about this. Let's create a new post-it note for it. It tends to work fairly well with business people. And business people are people that matter here, because we need their knowledge. And they tend to be slightly more outgoing than the average developer. We've got that big picture stuff. Now we need to sort of delve in a bit more. Something called user story mapping is what we call that. Each event, we now need to tease out, well, what does that event really mean? How are we actually going to translate that into software? What are the steps involved? You've probably heard the user stories. You know, we're fairly agile world nowadays. Agile's been around a little while. User stories as an X, I want Y to happen, things like that. So that Z magically works. Key thing here is the mapping bit. So we can all write user story. But what we're trying to do is we're trying to visualize the user journey and help our team understand the product functionality from the user's point of view. So not about our software. And again, it can be collaborative. This one here is obviously in person, but it works equally well using online tools, Miro and stuff like that. How do we do one of these? We have the concept of user activities, you know, those events that we had in the original, from the event story. And we have the steps belonging to them, which we call tasks. And we stick them at the top of the board, from this picture to the left of the blue line. Under each user activity, under each user task, rather, we put all the stories. So all that stuff are user stories. And it works out, you start trying to design a system, you suddenly end up with lots of user stories. So we have lots of user stories for lots of tasks, and now we need to ship. So you have to start grouping them, and that's where the map comes from. The blue lines going across represent releases. So this is release, next release, this is the release after. You notice there's no release after that. We're not stupid. There is no way that you can plan a release that far in advance and it will survive in release the first one. So don't even bother. Only worry about next release and loose plans for the release after. Anything beyond that, just don't worry about. It's not worth that time. So then we've got all the stories that we are planning to ship. And we've got them mapped out. We know whether we think they're important enough to be in the next release or whether they're not important enough and there's the release after. If they're not that important, they can probably be deleted. So it will never ever happen anyway. Which really upsets project managers at times. What I like about it being done in the physical world is that you get a sense of the scale of your software far better than when you do on a Jira Kanban board. Think about Jira Kanban boards or any of the other tools. Is that the size of your window affects how much you can see and you lose the big picture quite quickly. When you start putting it onto a whiteboard or onto a table, suddenly you get to see the scope of the problem you're trying to solve. And I think that's quite valuable for all the team to understand what we're building. And that tends to build better software. Event modeling. This is another thing we're doing to try to understand the problem so we can build the right software. What we are doing now is we're going to take those stories and create a blueprint for the solution and think about changes over time. Things happen over time. State changes over time. And we need to understand that if we're not going to screw it up. And you'd be amazed how frequently we screw things up. Actually, you probably would, you're all developers. We all know how easy it is to screw state up over time. This tends to be done electronically because you start hitting your URL diagrams and other tools that help make this easier. But what we're talking about now is we're looking at what happens to the life cycle of the data from the user's point of view for each key thing. This one here is some sort of to-do list, so we've got items, we're going to mark them as success, and we're going to store them, we're going to change their status. You can't have complete before you've got it in a to-do state and things like this. You start mapping that out left to right. Again, quite collaborative, detailed design work. It's all done quite agilely, this bit. This bit tends to be done by the time you're into a sprint. Between that lot, you've got a fairly good understanding of what you're building. But then you're luck, and you've done it wrong if you don't know what you're building before you build it. Again, I've seen that happen. It's not good. All those stories represent quite a complex application. And it's going to get more complex. If you've worked on an application, a piece of software, it's a code base, whatever it might be, for a while, has the size of the code base ever gone down? Has the number of features the software has that you've shipped reduced over time? It doesn't happen. Software gets more complicated. Software as a service makes it even worse because in order to get people to continue paying, you have to ship new features. Software gets more complicated. And eventually, Photoshop and Illustrator get so complicated that Figma comes out. That's not a surprise, but what's going to happen is that your domain model is going to start losing integrity. It's going to have new things bolted onto it as we start increasing the scope of our software. I keep using insurance examples because that's the world I know best in terms of this. But if we imagine we've got an insurance website that allows you to purchase insurance, we might now be asked to go to the next stage and do editing those insurance. So once insurance is undercover, we now need to edit those insurance. And as you can imagine, that is now a more complicated problem. And we've started introducing another area of the business who have got their own terminology. So our ubiquitous language is changing. They're using different words to mean the same thing because nobody can use one word for the same thing everywhere. That's what happens. And then maybe we'll bring in claims. And now we've got another whole in the people who've got a different view of the world that we want to put into our piece of software. How do we manage that complexity? Don't have to manage it. You can choose to ignore the problem. We call those people, well, we call those animals ostriches. And you know what happens to your software when that happens? We have a technical term for it called big ball of mud. And I know it's technical because it was in an academic paper. It's genuinely a technical term. To solve this problem, we take our model and divide it up. Obviously, very simple. And we call them bounded contexts, which is one of my favourite terms in DDD because it says what it means. Context, we all know what the context is. This is the context of purchasing the insurance. This is the context of making an edit to the insurance. This is the context of claiming on my insurance. Bounded, we are putting a box around it. We are protecting it. Within our box, we are in control. We own the terminology. We know what the meaning of the word customer is in the context of purchasing the insurance. Don't care what you call it in the context of claiming. In my bit, I know what the words mean. So we are divided and conquering. That's what bounding contexts are. Fantastic idea. I call it integrity. Everyone's used the word dilution. It's the same basic idea. We do not want to lose control of our model because our model is our understanding of how this process works that we have then expressed as code. One of the nice things about a bounded context is that we can change the words to match the business's use within each context. I quite like that feature as well. I like the idea that we can call our customer a lead when we're in the sales context, or we can call them a subscriber in terms of their newsletter marketing or something like that. We can use a better term because we have now started isolating. And we are now, again, going back to ubiquitous language, using the term that our customers are using. The people doing the social media for London Transport are not using the same term for the people subscribed to their newsletter as the salespeople are using for posting tickets. So we can separate the words out in our software as well and in our way we talk to people. And each one, put them together, and we create an application. So an application is normally composed of multiple bounded contexts. Each bounded context will be autonomous. Each bounded context will have authority within its space. It will own its own UI, or it will delegate it to a context that does the UI side of things. It's not necessarily a module. It is the obvious place to divide an application up if you are thinking about using microservices. I have opinions about microservices, which is most definitely not this talk, because that's another hour. But microservices are not necessarily bad. Where you divide your microservices matters as to whether it's a good or bad system. And the bounded context is the obvious place to do the division, not arbitrary size of micro. Monolithic applications, not a problem, but you need to separate out your contexts because they should have their own autonomy. Got all these contexts? To write it down, we have to give it a name because we are software engineers and we must have jargon. So our jargon is a context map. Context map is simply a pretty picture, or a not so pretty picture if I have to draw it, of all the contexts and how they link together. So in this particular example, we have 3 contexts, and we've linked the fact that a quote and a payment are related to one another. Better be aware that quote exists in sales because it will probably become a payment when we are booking the ticket. Or that a lead is a passenger, is a subscriber, is a user. Better be aware of that. So we have call it context map, but just call it diagram. It's just a diagram. Keep the diagram updated. This is by far the hardest bit of anything related to software development. Keeping the stuff updated. Legacy. One of the nice things about context map is that you're not going to have your entire application looking perfect unless you are greenfielding it and it's brand new. For the rest of us, we are adding new features and new things to existing applications. So there will always be a blob of the application source code that was written in parts that we have no clue what it does. And there are 5 people left in the company that are prepared to touch it. That's the legacy bit. Draw it on the picture. Just mark it legacy and put the word etc. in there. It's a fantastic phrase, etc. All the stuff I don't understand is in the legacy section. But don't pretend it doesn't exist. Just admit it's over there and we have not modelled it, but it exists in our software. It's incredibly convenient for communicating between teams. For any non-trivially sized application, you're going to have lots of people working on it. Diagrams like this help a lot for making sure that everyone understands what's going on. And that includes the business people. This diagram is understandable by my underwriter, by my customer service agent, because all the terms on here are the terms that my customer uses. You don't see the word queue on here, you don't see the word database on here. There's nothing that's related to the software implementation. This is a representation of how we've organised our model. And that's strategic design. It's all about understanding the problem space from your customer's point of view, from your business's point of view, and turning it into something that you can then turn into code. Now you need to turn into code. That comes to the tactical design. So tactical is a bit more down in the trenches. It's the patterns, the building blocks that we can use to actually do the source code. It's more hands-on as a result. This is where you start to see the age of the book. So the book comes from 2003, so it's getting on a bit. And we haven't stopped learning about software development, right? Which is a good job. We are always getting better at software development. As a result, DDD and the concepts of DDD And the concepts of the tactical design are important. The specifics, there's room for innovation. It's terminology that actually does help you to think about how to organise your source code and how to make sure it is maintainable in the long term. Entities, value objects, aggregates. You've probably heard some of these terms before, particularly because entities and value objects as concepts are really useful in all application development, regardless of whether you're using DDD or not. They're really good patterns. So a value object is an object that is expressed and identified by its attributes. They are immutable and interchangeable. So if we take an example of, are people still aware of cash? I'm aware we've all got on cards now and contactless, but in the old days there used to be this concept of £5 notes. In fact, you go back to my childhood, there's a concept of £1 note, but that's a long while ago. But the £5 note, if I've got a £5 note and you've got a £5 note, and I give you my £5 note and you give me your £5 note, we don't care. The particular £5 note doesn't matter. We just care that we have a £5 note. That is a value object. The thing is defined by its attribute. It's worth £5. Entities are defined by their identity. Each individual one matters. So each £5 note has got a number on it. If you are a member of the Bank of England and you are possibly dealing with a situation related to fraud, you probably care very much that my £5 note has got a different number on it to your £5 note. Each individual £5 note now has identity with its number, and that matters in that context. Which nicely takes my example back around to bounded contexts, and then it matters which context we are talking in as to whether we consider any given thing a value object or entity or whatever. The context we are talking about matters. So entities are things like users, are things like our tickets. They have got state, which is the number one enemy to simplicity in software. Unfortunately, you can't write software without state, otherwise our jobs would be really, really easy, and ChatGPT really could do them. As it is, state matters. Life cycle of state matters most importantly. The fact that something's got a username, something's got an email address, and we need to store it to a database, all of that happens inside entities and dealing with entities. Lots of problems require more than one object to actually talk about the thing we're talking about. We call those aggregates when we need more than one object to describe the thing. Classic example is the order. So if I'm going to purchase something from Amazon, my order will consist of the order object itself and then each line item, the things I've actually bought. So the aggregate of the order and its items is one thing that we have to think about as an item. So we call it an aggregate. Multiple objects have to be together in order to be a coherent whole. Again, really easy concept. Store in state. You need to store this state reliably. Generally, we store state in two places. There are more than that, but in general, there are two places. One, we store into a database of whatever form you wish to consider a database. I mean, some people think MongoDB is a database. MySQL. Redis. Or we store them to a web service. Pretty much it. We stick them somewhere else and someone else deals with storing them, basically. So we either offload the storage or we do it ourselves. We get the basic two choices. The code that you do that storage from is convenient if you can put it in its own area, its own class. And we would call that class a repository. That's quite convenient. It's not the only way to do it, and it's not necessarily the best way, depending upon the framework you're using and the way your application is designed. It's one of those areas where DDD is quite, the DDD book rather, is quite prescriptive on the idea that we separate out all these different things, like entities and our domain, from our persistent storage code. And we have data mappers, we have repositories to separate them. It creates a quite clean system, results in quite a lot of busy work as well for some type of applications. Sometimes it makes more sense to join the two together and have an entity that knows how to save itself. We call that the active record pattern. It's used in a number of frameworks, most famously Ruby on Rails uses it, Laravel uses it in PHP, are the two fairly big frameworks that use it. I think Django does as well in Python. It's a very, very common pattern and is completely compatible with DDD. So the important thing is the design of our entities and making sure that they represent the objects and the problem space we are trying to solve. As long as we can persist them, that's fine. Services. Not everything belongs in an entity. There are processes in your problem space that need to operate on multiple objects. When that happens, create a class to do the work. Call that class a service, and we're done. There's a whole load of other stuff in there around different types of services, like domain services, application services, infrastructure services. Doesn't matter. Immaterial. If the code doesn't belong to an entity, stick it in a service, and you won't go far wrong. There comes the architecture. You actually need to fit all these classes together into your application. Traditionally, we use a layered architecture for that. It's quite easy to understand. We separate out our application into logical groupings, layers, and each layer has a specific role. We have the presentation layer, that's the UI. We have the application layer, that's the bit that deals with pulling data from HTTP, sending a response out if it's an API, stuff like that. We have the application layer and the domain layer, where the actual work is done. And then we have the infrastructure layer, which is all the boring stuff. Probably better done that, but very, very loosely. Any piece of code that you can reuse across multiple applications that is a low-level piece of plumbing is basically infrastructure. Emails, login, stuff like that. Hexagonal architectures are where we put the domain in the middle and all the rest of the code logically around the outside. That can work quite well for some applications. Not particularly a fan myself, but you do see it used quite a lot. Personally, I prefer people think in terms. Personally, I prefer to think either in layered terms or in event terms. So an event-driven architecture is where we're going to trigger changes in our code. Trigger actions in our code based on events, changes that happen to state. Generally, we'll use a queue in these situations, so you don't have to. Some sort of message queue type stuff is fairly common. So you're going to have situations where an event is raised by this section of the software, goes into a queue, comes off the queue and is processed by another piece of software over here. It's quite a good decoupling mechanism, quite a good way to arrange the architecture of your application. CQRS. That's another common architecture. Command, query, responsibility segregation. It's not the best term in the world, is it? But command and query. So query means retrieving data, command means actioning data. Separate the two. Don't write one class that can save and load. Write two separate classes so that we can separate them out and optimize them independently of each other. When you do that, you start to see things like event sourcing happening, which is the idea that we have a list of immutable events that represent the state of our application. That has interesting complications when it comes to things like GDPR. If you're thinking about doing event sourcing, really, really look into it. Many ways to do your architecture. I practically don't care. DDD doesn't practically care, doesn't really matter. Just design it in a way that you and your team can maintain it going forward. That's the thing that really matters. So if I go sum up, DDD focuses on developing software from the business's point of view. You will have noticed I concentrated mostly on the strategic things, not the tactical things, because the strategic side is the bit that I think makes the most difference to getting successful software. The absolute worst thing you can do is work on software that then doesn't ship. The second worst thing you can do is write software that ships and doesn't actually solve the problem. Because that's just embarrassing. You're a professional. And you're going to solve the wrong problem if you have not thought about the problem from users and the business's point of view. And DDD has an amazing amount of tools to help us get that right. And to circle all the way back, the most important bit of all that is understanding what they are saying. Get a common language, understand and define all the words that are used by your customer, by your business, in their problem space, and then use them in your software as well, so that everyone is talking the same language. You will result in and deliver much better software. Leave you with this, a guy called Nick Cheen, who really does know what he's talking about when it comes to DDD. Domain-driven design is about creating shared understanding of the problem space, which is reinforced ubiquitously by conversations, code, and diagrams. Can't emphasize that last bit enough. The conversations, the code, and the diagrams, and all the documentation is all the shared understanding. If your code doesn't use the same words as your diagrams, you have an impedance mismatch and bad things happen. The wrong thing gets shipped, bugs happen, misunderstandings happen. That horrible, horrible phrase, "that's not what I meant," gets said. Thank you. Thank
you very much. The point about getting the language right, I think you mentioned when you were here before, and I've stuck with it. I'm like, that's in my head all the time now.
Good.
Do you want to QA? Or
We can take questions. Just be aware that we could be at the pub.
be aware that Rob wants to be it. Does anyone have a question? Dave's always got a question, obviously.
If you are working on a project that's been going on for some years,
Yeah.
and suddenly the business changes the name of something, like
Yeah.
one thing to another, what are your thoughts on how best to handle that? Assuming the business use the way that's the old
Right, now this depends upon the age and maintainability of your software. If your software is reasonably well maintained, has reasonable test coverage, is reasonably modular, then I would refactor to the new name. But I would try to refactor to the new name regardless. If I couldn't, then I would not introduce new bugs just to rename something. But if you cannot easily refactor a name in the software, then that word is already being used in the software to mean multiple things. So we have a problem in this code base anyway.
So refactor this line, then.
Well, ideally you persuade them to hire a really good consultant, hypothetically, and then we solve that one that way. Another thing you can do is start using the new terminology in the new work. So work changes over time, but you'll notice that any given piece of software, not all of the software changes much of the time. There are whole blocks of the software that never get changed because there's no need to. So we can isolate that lot into its own context. And then the new work, we can start putting into its own separate context. And now we can start using the correct terminology within that context. And then we have just an interface layer between the two. That's quite a good way of doing it. And if I was doing that on a production software code base, one that's in the real world, doing real work, making real money, I would do the change and extract out new bounded contexts at the point I'm doing work that creates value. I would just do it for no apparent reason. There aren't many of us who've got a job where we can just sit there for a year refactoring code for no particular benefit to the business. It'd be nice, but we'd be in academia. So that's not fair to academia. Not fair. So I would go that sort of approach.
So yeah, I'm not sure if this is the same question, but sort of, I'm just thinking about this case where in the companies I work, for example, there is a lot of this type of stuff, like people calling things this and that. Language just have this way of just being, like you can talk very vaguely and get stuff done in businesses. You're talking about experts in the field. There are some businesses where even the people who are closest to experts don't really talk exactly.
Yeah.
And in our code, so for example, you could have people, think about like things like shifts, like the business I work at. People say shifts for all kinds of stuff.
Yep.
And they all think they know what they mean.
Yep.
But if you wrote down your system in a way that everything is called shifts, things could get a bit complicated. I'm wondering, is it like a namespacing thing then, or how would you get around just vagueness baked into the?
Yes.
It doesn't matter for them because they don't have databases. They don't have to distinguish these.
Yes, they don't have two variables called shift in the same method. One's one type of shift and one is the other type of shift. But you have to know what the two different types of shift are. So they have more explicit names. But this is a really example of how humans work. Humans are really, really good at creating shortcuts to things. Funny enough, I've used one of the words that we use in the software industry all the time to mean different things, and that's the word service. Service has got so many different meanings, and shift I can imagine being another one in that sort of space. I would, in my software, I would have a qualifier next to each one. I don't know what they are, but work shift, night shift, whatever shift. I would do something like that in my code base. And when I'm talking to, I use the word domain experts because that's the terminology of DDD. But when I'm talking to a member of the company that is doing the processes that my software is for, they are the expert, even if they are not particularly expert on or have that sort of aura about them. When they use the word shift, they are all automatically have that qualifier in their head, even if they're not bothering to say it, because humans are incredibly lazy and we will always cancellate down as much as we can. If it's really, really clear whilst you're talking, then it's fine. If it's not clear, then I would clarify, we are talking about night shift here. And they go, oh yeah, and then they start using shift again, don't they? Because we're now back on the same page. So that's fine. What I would not do is have two classes called shift in separate namespaces. Me personally, I would always explicitly name the class with the qualifier. Mostly because the way my brain works, and I don't know about other people, but I've forgotten the namespace by the time I'm down in the class. And I would far rather have more text at the point where I'm thinking about the problem than the namespaces are all about organisation by code, far more, to me at least, than they are the nitty-gritty of solving a process problem. So I would rather have the qualifiers with the explicitness at the point where I'm writing the process code. Because that's normally where the bugs happen. We can normally find the other bugs quite quickly, but process bugs are difficult. So that's where I would want the explicitness if I could get it.
Would that distinction have to go in your ubiquitous language as well?
Yes.
Is that so?
Yes. 9 times out of 10, you end up with a glossary.
Yeah.
Particularly as an external consultant. It probably doesn't happen quite so much in companies because managers are managers. I'm on tape. Be careful what I say. But I've been in companies, so I was working for one client where we were working for a company in the in-flight entertainment industry. So they generated the software and the processes for doing in-flight entertainment. Every time they spoke, we created a new entry in a table, which was a glossary. And you end up with this glossary of all these terms. It feels tedious to write it, and it feels tedious, even more tedious to maintain it. But when you get a new team member, you've got to onboard onto that project, that glossary becomes golden. You've suddenly cut down so many questions for the poor sod who's now got to understand this stuff. Because they're going to read the code base, they're going to see night shift, they can go to the glossary and find out what night shift means in the concept of this, and it doesn't actually mean what they thought in their head. Because that always happened. I thought I knew what insurance was all about. It turns out I've got not a clue. From the insurance provider's point of view, I'm an excellent insurance customer. I'm really good at buying insurance. Not quite so good at processing insurance. What I thought meant cover meant, what I thought policy meant. Yeah, it was helpful to write down what they thought policy meant, what they thought risk meant. Because risk felt like a fairly safe. Oh, we all know what a risk is, don't we? It's fairly risky to jump out of an aeroplane. With or without a parachute. It's not necessarily what my underwriter was thinking. My underwriter kept using it in a completely different weird way. Oh, okay, that's what it means. And I wrote that down. So I'm not sure if I'm just rambling now. Does that help?
Yeah, I think so, yeah. With the branded contexts, how do you implement that practically? Does it need to be a separate database, separate code base?
So how do you implement bounded contexts, and do they have to be separate databases and stuff? Code bases and stuff? No, they don't. I do most of this stuff inside the same application, same monolith for a lot of the work I've done. Going back to what I said about namespaces, they work really well at this level. So I tend to group different models based on the namespace which represents my context. So I will have a claims namespace, I will have a, what do we call it? We call it sales. I'll have sales concepts, I'll have a I've got a sales namespace, I've got a claims namespace, I've got an MTA namespace. MTA stands for mid-term adjustment, which is their phrase for edit. So if I'm going to edit a policy or a risk or a trials or anything related to it, it's going to be an MTA. So I will have models in my MTA. And where there are differences between them, I will have a MTA risk model and I'll have a sales risk model if I need one. They might both extend from a common one when I can do that. Into the database depends on what I'm trying to organise and how I'm trying to save it. But it all goes in the same database because it's one application. And then I will qualify appropriately at the database table name if I need to. But it's not uncommon that I might have a claim or something like that in the database that is then used in two different contexts. But it's got different classes in the context because I've got different processes happening. So I will then have different methods within those two different classes. But the underlying data structure is the same because fundamentally it's the same paper form with the same bits of information written down on it. So play it by ear to a certain extent, but don't make your life more complicated than you need to because you have to maintain it.
Does that mean that the database, for example, would prioritize one term? So if you have like users, that is also a sale, which is a whatever. The database will actually just be user.
Now that is an interesting problem, yes. This is where the infrastructure side of DBD becomes quite interesting. But yes, I would pick the primary term for the core domain. It's the one I would pick for a database if I possibly could. So if I go back to my rail example, I would almost certainly use customer or passenger. Nowadays I'd use customer, of course, because we don't have to have passengers anymore, they're all customers. I would use customer over, for instance, subscriber, because the bit about dealing with newsletters and subscribing for the marketing stuff is clearly a subsidiary domain to the core domain of the software, which is around purchasing, say, or whatever. So I would pick the core domain if I possibly could. If I've got multiple, then there's a certain amount of first one wins, practically. The one you write first is the one that's going to adopt as a database table name. And lastly, I will abstract if I need to. But then that gets dangerous because I create an impedance mismatch. And I start having a table in my database that doesn't match the guest names in my code base, and now I've got hard work for the rest of my team. So I will try to avoid it if I possibly can. I don't think I've done that, but generally core domain is one I will pick. And it's fairly usual that core domain is the first domain you work on. If you're starting to have a second domain that is as big or bigger than your core domain, you've almost certainly going to refactor your code base, or you've got two separate applications, in which case the problem goes away at that point anyway.
Do you use the aggregate routes if you store them together? Because you're talking about entities now, right? So what's your experience in using the aggregates?
I don't use aggregates very much, but they are always, or they have always been class constructs. They've always been classes in my code base, not records in my database in that sense. Because normally they are a group of things that I want to think about together. Particular example, like I might have, if I'm planning a journey on my tube map, I might have a route, concept of a route, which has got a start and a stop, which are both stations. So I've got two stations that have to exist for a route. I would be thinking about, my aggregate is my route with the stations in it, but I wouldn't necessarily need a database entry for that. So of course, if I've got a bookmark in there, maybe I start needing marks, so it depends on how the scope creep goes.
Have you ever done the opposite?
If I ever, what's that?
Have you ever done the opposite? So you have the aggregate in the database and the entities in the code base. So when you get the full block from the database, then you get to the
Now that's a good question. I haven't, because I've not done much database, document databases. I imagine if I came across a job which had a document database, that's probably more common. But I've not actually done that myself. At least not the stuff I've done. An awful lot of my work is, for want of a better phrase, legacy, enterprise, old. They're good words. Mostly because those sorts of companies have got enough money to pay me, which is quite nice. And they have profitable software, which is also quite nice. And they tend to be more long-lived applications as a result. So no, I've not come across that yet. All questioned that? Thank you, Odette.
Let's look that way. Yeah, nice one.